So microservices, before going into microservices, I would like to just briefly touch upon a 4+1 model. It was an effort done by an software architect working at the Hughes Aircraft of Canada to basically understand a different point of views, right? Architectural actually from different point of views. Why? Because let's say the software developer, they have a different view of the system, and architect have a different view of the system, the business stakeholder, they have a different view of the system. And he wrote a paper to help us understand how we can categorize these systems into a sort of different ways and come up with this logical view, right? There's 4 different categories, which we say like 4 different categories, and then there's a one in the middle. That's what there are actually 5 different views, but this view is so important. Like this basically sort of drives all the different other views. That's why he named it as a 4+1 view model. So let's discuss about this. So logical view is that about how from a developer point of view, I'll say what are the different classes, what are the objects, state machine diagram, interaction diagram, or sequence flows, sequence diagrams, how these interact, components are talking to one another from an coding point of view, right? So this is what developers create. There are some classes and packages, right, and relationship between them. So this complete diagram is from monolithic point of view. Just consider this from the monolithic point of view. And why I bring it up here is in the microservices is just to give an idea that how this is different from microservices point of view, right? And then comes as the process views. So the process views are basically for seeing that what are the concurrent processes which are running in the system, and they also answer some of the non-functional requirements of the system, right? We have a functional requirements, which are the main business requirements which you want to answer with a software, but non-functional requirements are more of like security, what are your compliance needs, what is your performance, all of those kind of things, and they can be easily explained using this process view. So one of the example of process view can be an activity diagram, right? So this is important from a business stakeholders point of view as well, because business users, when they create a new system, they often create this business flow diagrams, all that, to understand the interactions that will need to make from let's say BPMN point of view, business process modeling notation, that point of view. So this is one view of the system. So this is a process view. This is one view of the system. Logical view is one view of an architecture. This is more for a developer. Process view is more for architect, for business stakeholders, right? And then comes the implementation view. So implementation view is more like what will be the output of the system. For monolithic, it is a var file, executable, a single EAR file, right? For the microservices, it will be a multiple deliverables, or these such executable files. So that's what this implementation view is. And also we will see if there are multiple, then what are the dependencies of these executables, right? How we can build this system, all of that. So then lastly comes the deployment view. So deployment view is mostly from more on a physical layer. How let's say you build this system, then how they are running on the machines, or how they're executed on the nodes. So this contains different deployment diagrams from the UML to understand that. And here if we have that, you must have seen like from the AWS, there are different architectural deployment view diagram. You'll see there's a load balancer, then there's a VPN, which is a private network, then there's a gateway, and in VPN you have a various subnet, and subnet you have EC2 instances. What are the networking you are doing, what are the ports you have configured, all those sort of things. Deployment point of view, they comes into this deployment view, and this is very important from an architectural point of view. For an architecture to understand some of the address important question about the non-functional requirements like security, compliance, all those things are very important. So now the last thing is this scenario. So this scenario you can simply is a rename for use case view. So why this is so important, that let's say you have built all these things, right, but without a use case, without a proper use case, that how you want them to orchestrate, how you want to run. That's the question that is answered by this scenario or the use case view. So yeah, this is what 4+1 view is. And now we can just step back and sort of look from a microservices point of view as well. This same thing in microservices view will have, in microservices architecture will have different logical views, right? Because you are creating multiple services, and for each of these services you need to have different classes and packages created. You need to have different processes too, different processes for each service. Now you're defining, earlier you were defining at just one one stage. Now you're defining in terms of how one service will connect to another service and in which way they will be talking to one another. Sometimes we call this as like choreography, how they talk to one another, right? And implementation view, like I said, this is for the monolithic, this is a jar file or single executable, but for the microservices, they're basically the REST calls between one another, or not just REST. It can be another API, it can be GraphQL, it can be gRPC, it can be and another remote procedure calls too. So these are two multiple. And deployment views, I will say, yeah, deployment view is still like you can have one collaborative big deployment view, but the way that deployment is done is a bit different, because we'll be needing some help. We'll be needing some help from frameworks such as Kubernetes, a service mesh. So all these things we'll discuss later on. So what I wanted to discuss here is that this 4+1 view is sort of different from the monolithic point of view and from the microservices point of view as well. So this diagram shows an example of a microservices architecture where you have different front-end channels, and you can have a sort of gateway API. This is also one of the design pattern. Design patterns are basically the recommended ways of a common problem. They're recommended solutions to a common problem, right? So yeah, it's just like we have one API gateway. So you make this request to different services. This will decide which one it wants to send it to based on, let's say, a path or what kind of request it is, different kinds. So yeah, so this shows that this different services, they have APIs and they talk to one another with the using this like REST APIs. They are most famous, and these services itself, they are solving one business problem. Sort of we are using DDD, which is domain driven design, subdomains, to basically address to basically decompose them to different services, right? So yeah, and they have their own local data stores, and maybe you can have some shared data stores as well. We'll need those too, but yeah, mostly they have a local data store because it's more closer, and it's just more faster. Maybe let's say these 2-3 or microservices, we want to run them on one node, and they want to share the data on that node. So then we can have it in a way that they can share those data store on that particular node. So these are all possible cases. That's also a possibility. But overall, this is how this microservices architecture looks like from an application point of view. Just the difference from the SOA is that we have this databases here, and more REST APIs, more fine-grained things. So yeah, so now let's some of the advantages of using microservices. So first one is different technologies. I'll not now discuss them too deeply because I think I have earlier discussed them quite a lot. So earlier in the monolithic way, you were not able to change the language, but now it's a more polyglot. You can change the languages the way you want, because now you are basically talking using this REST APIs, right? So they can be different, even though the technology underlying is different, but the request and response will be let's say a JSON. So it's actually respecting. So if the API means that you have a sort of contract, right? So one common example of API is that you go to a restaurant, you book an order, and then you put it there, and then there's a chef that will make a cook for you, and you'll get your meal. So you have a contract, you give the order and you take your meal. Now if there's a new chef there, but if you order and you get the meal, so it is same for you, right? So like the same way, so the API is sort of the contract. So even though you change the technology, at the service level you're fine. The app will still work. So this is what we are differentiated from the monolithic. But in the microservices, but in the SOA, we already had that distinction about from the services point of view. Yeah, this is a big advantage. They can be scaled independently. Now, as per demand, they can be scaled because the way they are structured, right? Now we have services. If they're running on the pods, we'll see that how this is possible. But I think this is quite evident that now we have different services running on the pods, running on services running on the pods, and pods on the nodes, and we can scale them such that on one node we can have 10 services, 15 services, the way we want, and they can be independently developed. Yeah, that's true. Different versions of this applications. Yeah, now we have. Yeah, it's easier using this like a framework Kubernetes, which we'll discuss later on in some later videos. So using that, it's quite easy for us to maybe have a different application, different service. Now it's just at a different version. So still, we are having different of the services at the different versions talking to one another. This is possible. Maintenance is faster. Yeah, now let's say there was a bug. In case of monolithic, you have to see, okay, where is bug, and you have to build the whole app, and then you have to deliver it as a patch. But this is more faster, right? Because if you have some issue with the order microservice, then you go to that order microservices and make the change. So it's faster to understand, faster to deploy, faster. Everything is faster. More reliable. Yeah, because earlier we took that example, right? Because in there we had in one service failure that has a sort of cascading effect on all the other services and ultimately that brought the whole system down. But here we have some ways that we can avoid doing that. And that's another decision that we need to make now, is that do we really need that microservices, because it comes with an additional complexity about deployment and everything. So that's another question. But the advantage here is that for the complex application, my advice is that we should be using microservices architecture, because even though it's earlier we'll feel that for the deployment it's just taking more time to build, but ultimately it will be more agile in nature. And finally, I'll say microservices is not a silver bullet. It's a kind of a well-known phrase over the internet as well. So yeah, it's not a silver bullet. It's not that you put it there and it will solve all the problems with you, all the problems for you. You have to be extra cautious, and you have to make sure that you're doing the right thing the right way. So yeah, let's discuss some drawbacks. Like I said, complexity. Yeah, it's a complex. We need to implement the inter-process communication within a service. That's what we need to take care as a developer. We need to deal with a partial failure. Yeah, in monolithic, let's say something fails and you will know, but in this case you will know, okay, where this thing has failed. exactly we need to figure that out. So that's added complexity. Yeah, there is something called as stateful and stateless microservices about the states, and that needs to be handled differently. If you have a stateless service, then it's fine, you can put a database on that service, and every request will be sort of idempotent, so the request can go to any of these microservice. But what if you have a sort of like session based request, where for every request you want its previous request, what was being made, that's also, that history is also attached to that. So for that, the service you have is more stateful, and for that you cannot have a database which is just residing inside that microservice. So overall, this is another challenge, microservice, that we need to see. So testing interactions, yeah. So like I said, this has for testing, basically the integration testing is challenging, because now you have these different services running here and there, and you have to test them and to see different things. So testing interactions are difficult as compared to the monolithic, because they had everything deployed in one piece, but here it is not. It's just like you have to deploy it deploy one pod and deploy another pod and have to test them. Deployment, yeah. So deployment, let's say for monolithic, you have to deploy something, you can just execute it one go. But this is from here, this is more challenging, because you have to spin up this all these different services, and maybe one service has different readiness that you have to wait for some time, and then how they should be, the order they should be started. All of those things are there, right? But we have the tools. We have there's something called Helm charts, which is a sort of a package manager from a single point, how we can manage, how we can deploy the Kubernetes cluster that is being taken care. Then we have another elements like service mesh, like Istio, and Kubernetes itself. I think these are the three main sort of elements which can help us in deployment of this microservices in easier way. Yeah, it may cost more than monolith, because we are having this additional infrastructure. If you're using them as a managed infrastructure, let's say for Azure we're using AKS, then things become a bit easier. But yeah, you're ultimately paying for that additional compute that is happening there instead of like the monolith. More overall memory consumption, that is true. Let's say you have an monolithic application where you have n servers, but now what you did is you took this n server and bring this m services here. So now let's say this n servers, they need JVM, they run on the Java virtual machine. Now what will happen, all this n into m services, they will need JVM, right? So there's a additional compute which will be needed. And even we have seen that the database we are putting into each service. So yeah, there's additional compute, there's additional storage, additional networking that we'll need to pay for this resources. If you're using even on-prem, if you're using cloud, like in both cases we need to pay. We are almost reaching the end. Okay, so here I put some of the examples of to basically to give you just an idea in terms of how they look like. So scaling, we have already discussed it. So in terms of microservice, right, the scaling is such that let's say on a server 1 we can have one process of, let's say, Blue, and two processes of this, but in server 2 we can have them the way we want, we can scale them the way we want. Let's say we have an application such that this green sort of services or processes, they need more, they are more in demand for some reason, so we spin up more of them, right, as per the demand. So that's something we have already discussed how the scaling is being done in microservice. And dependency management, yeah, so dependency management is another, I'll say, challenge in microservice, but there are ways to do it. But if you see here, this is a monolithic app, right? And this monolithic app has it needs this library A, and the library A and B both needs library X, and library C needs library Y. So now you did what you have built the 4 services here, but overall this is just one service, like in a monolithic. But if you go for the microservice way, you said, okay, I'll put them to 4 different services, and now same thing. This one needs library A, and library A needs library X. That's fine. So application 2, let's say it needs library A and C. So A needs X, C needs Y, as you can see. Okay, so if application 3 needs just library Y as a dependency, then this also needs Y, C, then they both need Y. So here you see that the difference is that there is additional duplicacy, right? So this X, which is a dependency, so it's being replicated here and there as well, because they are running independently. They are running on a different part, right? So yeah, that's something to be aware of. That dependency management of these things are different in monolithic and microservices way. So some key characters of microservices, I think we discussed it, just a rapid repetition. Microservices is SOA 2.0. These are autonomous services. We define them on a DDD functionality. They should ideally be responsible for a single capability as per solid principles, and where S stands for single responsibility principle. They have their own data store, and using this, it will reduce it will make them loose coupling. We call it as a loose coupling, and more cohesive. If they're more cohesive, then they're doing the things, one thing, just one service is doing one thing, and then they're more cohesive. They can scale independently. So choreography is something I want to point out, that these services are now responsible for the way they want to handle the request. So that's something called as choreography. Let's say a user places an order, and this order service has to make sure, okay, if this is about transaction, then it will come here, and if it's about no fees, it will go here. If it's about this, it will go here. So this is a more of an event-driven approach. If this event come, go this. If event this. So that's something choreography. This is something we need to do at the service level for each service. And service discovery, yeah, that's another challenge. Now let's say you have all these services, thousands of these services running on your backend. So a service A needs service B, so how it discover where the service B is there, right? So you need a service mesh here. So there are some other ways to, but this is also a challenge. Service discovery, which can be client side or which can be server side. We'll touch upon these things later on, but here I put it just to give an idea that these are the things which are there in a microservice that we need to take care of. Another challenge, they are more distributed now. All these services are more distributed. Now we have to secure them. Let's say we have to secure them at every place, right? It's just like you have a big giant mansion, you can put a one gatekeeper in case of monolithic, but now you have divided it into small rooms and all that. Now you have to take care of each of them separately. So there are more ways in this it can be attacked, and we of course have a role-based access control. We have a way to handle authorization, which service can talk to which using a service mesh. So yeah, this is something that we'll need to take care of. So, but here I mentioned it as what are the challenges in microservices. So configuration management, if you have to manage the configuration of this application from single point, that's another challenge. And log aggregation, because these services now are generating the logs, right? So earlier, in case of the microservices, these logs were mostly just on a single point we'll able to gather them, but now we have to find a way that we can consolidate all these logs in these services, and then we can make inferences from this. So this is also a challenge in that. So we need to use some log aggregation tool, use Splunk or some other tool, or you go with Kubernetes has something as well, or you try to create something on your own. This is almost second last slide. Okay, so we are almost done. So handling cross-cutting concerns. So cross-cutting concerns, I have already mentioned what they are. So they are like those things which you cannot really separate out from your service, that they go along with your service at each and every part. So what the way to handle this thing? This is a concern, but there's a way to handle this. The way is that we can build something called as a sidecar container. So let's say this is a microservice one container and there's a sidecar container. So all sort of that that part of the common responsibility that we need to do for security, logging, metric collection, audit. So these things can be taken care of by this sidecar pattern. So yeah, this is the last slide. Here it shows you an very small microservices based web app example. So you can see that we have a front end, and for each of different kind of request we can have, this is just say a web page, a div, one div, another div, input file, and the submit button. So each of these things are, when you click on those, they talk to backends and the request, and we have a get calls. These is different endpoints, and we have an API gateway. So the only different thing here is that you have a more fine-grained microservices here, which are sort of choreographing, where they're event-driven based, they're calling to one another. Yeah, I think that's a very high-level overview of microservices architecture. So yeah, thanks a lot for if you made it to the end. that's great. Thanks a lot for watching this, and I know that has been quite a while that I made a video, so I'll try to make the coming videos smaller. I didn't know that it will take this much time. As I said, that this is just the second video I made on YouTube, so hopefully I'm aiming to make smaller videos, 10 minutes, 15 minutes, because even if I go to YouTube, I don't want to see longer videos. It's really hard, but it will take me some time to go there. And also, if you have some suggestions for me, please feel free to put it in the comment box. It will be really helpful. And if you can subscribe and like the channel, if you like the content, then please subscribe. If not, that's okay. But yeah, thanks a lot for watching. Have a great day.